Hi guys, how are you? I'm sorry I'm not here with you in class today. I've had surgery. They removed a kidney stone from me. So I'm a little bit tender and not able to go back into work just yet. I should be back midweek sometime. But I want to be able to give you some advice on how to work forward on this booklet here, Sequence and Series number 1. So that's what this lesson is all about, and I'll help you get started on it. So we're talking about Pre-Calculus 12, Sequences and Series number 1. Okay, so the first thing that we need to talk about is what is the difference between a sequence and a series, and what is the difference between arithmetic and geometric. So a sequence is just a set of numbers that go up by either a common difference, so like over here, 2, 4, 6, 8, 10, 12. So this is a arithmetic sequence that's going up by a difference of 2, right? It's going up by 2, so I keep adding 2. Down here, this is a geometric sequence, and it's going up by a ratio of 2, so I'm multiplying by 2 all the way along. So arithmetic goes up by adding, geometric goes up by multiplying. And so we can also go down, we can also subtract numbers, that's included in arithmetic, and we can also divide numbers, that's included in geometric. So that's arithmetic and geometric sequences, and a series is the same set of numbers just with pluses in between the numbers. So let's have a look at what that looks like. Okay, so here we are, right? An arithmetic series is just the same set of numbers but with pluses going on in between them. And geometric is the same thing with pluses going on in between them. So whether they're just numbers or whether we're adding them up, that's the difference between a sequence and a series. And there's a bunch of formulas, and really this booklet is quite formula heavy. So I'm going to write out the formulas for these, and we'll go over the use of some of them. And that'll help you get started in your booklet to help understand what these things are doing and what we're talking about. Okay, so the first formula for an arithmetic sequence is Tn is equal to a plus n minus 1 times d. A is your first number, n is your number of numbers, d is the difference, and Tn is your last number. And it's just a formula. And so, I can give you, different pieces of information within this formula, and you'll be obliged to either solve for Tn or solve for one of the numbers inside the formula. And we'll go through a couple little examples like that. The one for geometric is this guy right here. So Tn is equal to a times r to the n minus 1 as an exponent. And this is a unit on logs, right? So logs are used to solve for exponents. So this formula we're going to use, and it'll be what we wind up dealing with in order to, to illustrate our log knowledge. But again, a is your first number, r is your ratio, in this case 2, n is the number of numbers, so depending on what I tell you, and then Tn. And sometimes we give a little number for the n, that's your very last number, sometimes the number you're looking for. I'll write up the other two over here. We won't talk about them just yet, but we will be talking about them shortly. Alright everybody, so the sum of this series can be written like this. Sn, the sum of n numbers, is a plus Tn. You get the Tn from this formula over here, so sometimes you have to do a little pre-calculation in order to figure it out. Okay, times the number of numbers, so sometimes you have to calculate n depending on what you have to do, and we'll look at an example where you have to do that, divided by 2, so it's just another formula, right, plugging things in and calculating them out. And for geometric, there's two formulas, here they are here. Depending on which information is easier for you to access from the question, you either use the first one or the second one. And so let's have a look at a couple examples. Okay, so let's say I ask you to determine the 53rd number in this sequence. And we start off with 21 and we're going to go down, right? So 21, 16, 11, 6, and I want to find the 53rd number in this sequence. So I'm just going to set up the formula and plug in the numbers that I need to use for that. And so this is a arithmetic, right? We're going down by a common difference of 5, so the difference is negative 5. And well, my last number is n is equal to 53, right? Tn, so T53. And it would be 53, and so let's write out the formula and what it looks like. Okay, so it's an arithmetic sequence. You got to make sure you get the right formula. Okay, so I'm asking for T53 of the 53rd term. So that's a little clue as to what your n will be, right? Sometimes they write it for you there. A is your first number, so 21, times n minus 1, so 53 is your n number, minus 1, and times the difference. And the difference is 1 going down by 5. So let's calculate that out. Okay, so I just filled in the number parts, and yeah, there it is there. So when you calculate that all out, you get negative 239. So in this spot, the 53rd term would be the number negative 239. Okay, so let's have a look at a couple other examples. Okay, I may ask you to do something like this. How many terms are there in the sequence, 3, 8, 13, 18, all the way up to 1248? Right, so how many terms are there? And again, it's just applying the same formula. This is an arithmetic sequence, but now we have to do a little bit of algebra. So let's set that up. Alright, so we would notice that the difference is 5. Like there's a 5 between each of the numbers, and so if I plug those in right to my formula, I get Tn. So that's my last number, 1248. A is my starting number, 3. N is what I got to solve for, and then D, well, D is the difference of 5. So I got to sort this out. I'm going to have to factor a bottom of that 5 right there. So let's have a look at how that works. Okay, so I factor bottom of the 5, and I've got this algebra expression over here to have to sort out. So I just got to solve for N. Easy peasy solving. Okay, so gathering like terms on the right hand side, and then I got to solve for N. So add 2 to both sides and then divide by 5. Okay, so 1250 divided by 5. Okay, so divide 5 to both sides, right? Divide by 5, 5 to both sides. So N is equal to 250. So there's 250 terms in that sequence. So what if I asked you to add all those numbers up? What would it look like if I asked you to add those? What would the sum total of all those be? So same set of numbers, but I want you to add. So you have to go to the series formula because I'm adding them up, and then I have to fill in these parts. So A is your first number, Tn is your last number, N is the number of numbers. Now we just calculated that. So we just plug them in and we calculate them out. Let's see what we get. Alright, so I plug them into the formula, and there they are. And now I have to calculate it out. So, proper bed mass, and away we go. Let's calculate it. Okay, so there's my number down there, 156,375. Bada boom, bada bing. Okay, now sometimes if I gave you this and I didn't tell you anything else, you might have to calculate N, and that's implied inside the question. So sometimes if you don't have all the pieces, you have to figure out how to figure out what to get from all the pieces, and that's why you're working with your formulas. And that's part of why I'm getting you to think about those formulas and those questions in the booklet. There's a couple other details I want to talk about, so I'll do that. This is a two-part series, so I'll have to talk about the other part shortly. Okay, so this will be something you'll see on your unit test because it requires us to use logs to solve for this. So it says, how many terms are there in the sequence, blah, blah, blah. I guess sequence should be having commas, right? And so how many terms are there in that sequence? Now you could try to count it out by hand, and that's fine, but this is a unit on logs, so we want to be able to show how we know how to use logs to solve for that. So this is a geometric, right? We're going up by a multiple of 2, so 1/4 times 2 is a half. If you're not sure, you can just take two numbers and take the one after it divided by the one before it, and you'll get the ratio. So 1/4 times 2 is a half, times 2 is 1, times 2 is 2. So my ratio is 2. And let's have a look and see how we execute this type of question. Right, so there's our formula. We're solving for n. We want to figure out the number of terms, so it's in the exponent position. So yeah, as you recall, right, when you're solving for exponents, you need to use logs. So we're just going to fill in the numbers for the formula and work to calculate it out. Okay, so I just plug in the numbers, right? Tn, right, that's our last number, so 8192, right, that's over here, that's Tn. Equals a quarter, so 0.25, you can write it out as a quarter or the decimal version for it, times r, the ratio, we know that the ratio is 2, times to the power of n minus 1. So we got to solve for that n, right? And so let's have a look how that's done. We have to divide off the 0.25 first. Okay, so when I divide off the 0.25, 8192 divided by 0.25 is this 32,768 is equal to 2 to the n minus 1. So I have to solve for n minus 1. That means I have to, well, use logs. So let's see how that works. All right, so let's okay, so I want to fill in the blanks for this arithmetic sequence, and I have to tell you whether it's arithmetic or geometric because it depends on how it has implications about how to set up the algebra for it. And the algebra setup is quite important here. So what we can say is that I'm starting off with the number 5, and through adding the common difference, what is it, 1, 2, 3, 4, 5 times, I'm going to go from 5 to 35. So let's have a look at what the algebra would look like. And this algebra setup is the key part. Okay, so 5 plus 5 differences gets us to 35. We write it like that. And then, well, 5d's, we can just write it like this. Okay, so that's a simple solve. Let's solve it. Yep, minus 5 to both sides. So look at 5d equals 30, so d is equal to 6. And that tells us what the difference is. So we can fill in the blanks now that we've calculated the difference. So we just, add in the numbers. So here we go. Right, so we know that the difference between each of the blanks is a value of 6, so we just add 6's to 5, so 5, 11, 17, 23, 29, 35, we add another 6 is 41, and going backwards, well, we just minus 6, so 5 minus 6 is negative 1, so boom, just like that. Let's have a look and see how this plays out with geometric. It's a little bit more challenging. Let's have a look. Okay, so this one is for geometric, right? How many... we have to figure out what the ratio is, so how to fill in those blanks. And so we're going to need the geometric formula for Tn, or not for Tn, but for the algebra setup. So let's have a look at that. Okay, so there it is, 3 times, well, there's 6 r's, right? So as you can see, and so how do you solve for r? Well, we have to use exponents. So let's have a look at that. Okay, so that's 3r to the 6th power. So now I have to solve for r, so divide off by 3 first. Okay, so r to the 6th power is equal to 64. So to solve for r, we need the 6th root, or the 1/6 power. So I'll just write it as a power. There it is. You could call this the 6th root of 64. It's the same thing. So we got to calculate that out. Now be careful, right? Because this is an even power, we're going to have both positive and negative numbers. So we're going to have to calculate the 1/6 power of 64. Okay, so on your calculators, you're going to want to type it in something like that. And that should give you 2 on your calculator, but remember it's plus or minus 2. Okay, it looks something like that. So we can multiply by 2's or also negative 2's. And so I'll write it out with the negatives in there so you can see how it alternates. And then, yeah, we'll talk a little bit more about that. Okay, so if I'm multiplying by negative 2's, I go 3, negative 6, positive 12, right? So the negatives alternate. And so here we are, negative 96, and then positive 192. The negative 38, and if I'm multiplying by positive 2's, then everything just stays positive. So whenever we have our negative, we have to include the plus or minus symbol on those ones. But if it's already positive, right, if I'm timesing just by regular 2, then this is going to be regular 12 no matter, what we do. So the negatives, they will alternate, and the positive ones, they'll hang out. Okay, so there we go. Looks like that. And that really takes us to the end of your first lesson for this booklet. I'll have another video ready for you for the next part of the booklet. We're going to apply this idea to something called a bouncing ball. So yeah, we'll look at that next video. All right, so take care, everybody. Hope to see you soon. Bye for now.